Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on differentiation using the chain rule. And in this video, I'm just going to be going through an example of an application of the chain rule where we go on to find the tangent. Okay, you'll have seen the full question in the little screen at the start of this video. So I've just jotted down the key information that the equation of the curve is y equals 2 over 2x minus 1 times x plus 3. And that we're being asked to find the equation of the tangent at the point P, which is -1, -1/3. Okay, right, tangent, straight line. What's the two things you need to find the equation of a straight line? You need the point and you need the gradient. What's the point? There it is, there's the point. That's the point we know. So the other thing we need is the gradient. Where's the gradient coming from? Well, if we don't have two coordinates, if we don't know points, the gradient is coming from the function differentiating it. So I need to differentiate this to find a gradient function. Now the first thing I need to do is consider which rule I'm going to use to differentiate this. Obviously I'm going to use the chain rule because the lesson's called the chain rule. But before I can use the chain rule, I just need to expand out the denominator here so that I've got one single function, because at the moment I've got two functions being multiplied together. So the first thing that I'm going to do is I'm going to write that y is 2 over 2x squared plus 5x minus 3. I'm just going to put a bracket around that because it shows that it's one function, and it also shows us what we're going to do next to enable us to use the chain rule, where you have to have function power. We are going to write y equals 2 bracket 2x squared plus 5x minus 3 to the power of -1. And now I've got it in the form where I can use the chain rule. Okay. So just like in the previous video, chain rule, power down. So -1 multiplied by 2, and then the bracket doesn't change. Reduce the power by 1 to -2. And multiply by the differentiated bracket. Now, be careful, got to differentiate this whole bracket. 2x squared differentiates to 4x, plus 5x differentiates to 5, and because I have two terms, I need to put a bracket around those two terms. Now, what have I got? I've got -1 times 2, so that's -2. So I've got -2, 4x plus 5, multiplied by 2x squared plus 5x minus 3 to the power of -2. And what I am going to do here is to write this as a fraction, because it's going to make my substitution easier in a minute. So I'm going to take my time, I'm going to write this as dy by dx equals -2 times by 4x plus 5 all over 2x squared plus 5x minus 3 squared. So that 2x squared plus 5x minus 3 to the power of -2, that bit's like having the reciprocal 1 over, so this bit goes underneath and you're left with -2, also 4x plus 5 on the numerator. So this is the gradient function, this is what we use to find our gradient, and we want the gradient at this point here, -1, -1/3. So we use the x coordinate, which is -1, and we substitute it into dy by dx to find our gradient. So dy by dx is going to be -2 times by 4 lots of -1 plus 5, all over 2 lots of -1 squared plus 5 lots of -1 minus 3 all squared. So 4 times -1 is -4, plus 5 is 1, so times by -2, I'm going to have -2 on my numerator. -1 squared is 1, so I'm going to have 2, take away 5, which is -3, take away 3, -6, square that is positive 36, so -2 over 36, which means that my gradient is -1 over 18. So I've got my gradient, I've got my point, and I can now stick that into my straight line general equation formula, which I'm just going to do here. Now remember, it's y minus y1 equals m bracket x minus x1. Don't start messing around with y equals mx plus c, because the form we've been asked to give our answer in is ax plus by plus c. We've got a fraction as the gradient. This form makes that so much more straightforward. Right, so y, take away y1. Now, subtracting negative 1/3, it's going to be plus 1/3. It's going to equal m, which is our gradient, negative 1 over 18, multiplied by, in the bracket, x minus x1. Subtract negative 1, you're going to have plus 1 here. Now the bonus of this form is I've got a fraction here, so I don't need to worry about expanding the bracket out. I can just multiply both sides by that 18, which gives me 18y plus 6 equals negative 1 times by x plus 1. So then 18y plus 6 equals negative x minus 1. That's expanding the bracket out. I've been asked for the form ax plus by plus c equals 0. So I'm going to add that x over to make it positive, plus 18y. Add that 1 over, make it positive, 7 equals 0. And I could then state that a equals 1, b equals 18, and c equals 7. But the important bit is that the equation of the tangent to the curve is x plus 18y plus 7 equals 0. So, tangent, straight line, you need a point, you need the gradient. We had the point, we got the gradient by differentiating using the chain rule and substituting in the x coordinate, and then we used our equation of a straight line to get to the tangent